All right. Hello, hello, hello. Hello guys, how are you doing? Today is a new day and we'll be continuing with our series on data structures and algorithm. Basic level data structures and algorithm. And to be specific, I've been covering linked lists for the past 3 days, and this is essentially because I wanted those who are not familiar with linked lists to really familiarize themselves with linked lists. And in case you were not here for those 3 days, I think you can look at the videos from day 98. Sorry, 96. I think 96 to this day, and you will have access to all the recordings on linked lists. Right. Okay. That aside, I think um today is the day before the last day. So unfortunately I'm starting late. I would have streamed earlier, but you know I had a lot of things to do. So anyways, it's better late than never. So let's continue with the list I prepared. So we previously looked at how to create a linked list, how to print the notes in a linked list, how to insert notes in a linked list. We looked at the how to find the middle of a linked list by using the FCF method, which is the Floyd cycle finding algorithm. And we also looked at how to find the middle of a linked list using the iterative approach. And we looked at how to reverse a linked list. We looked at how to implement a linked list cycle. So I did that yesterday. Um, and then we also looked at how to, okay, we solved a couple of questions made of a linked list. These questions are actually related to the topics I've covered. So as you can see, this is somewhat a master class, right? I will not call it a master class, but like an introduction, an introductory lesson to linked lists. So this will help you understand linked lists. If you follow the different topics here, like the way I arrange them, right, in this order, and then you'll be able to solve after covering all of this, right? You'll be able to solve the middle of a linked list question on Leet code. Um, you might probably struggle with this a little bit, but I think with this you're all right because you would have seen how to reverse a linked list here, and then you will look at how to remove. So we are going to do this today. Remove linked list element. Okay, we are going to be removing nodes from a linked list. Let me open this. So yeah, we're going to do solve this question, but with the different topics here, right? If you've gone through all of this, you should be able to solve these first three questions, right? Made of a linked list cycle might give you a little bit of trouble, but if you watch my video from yesterday, you should be able to you will be able to solve this, right? It will become easier because I actually explained how um, everything works internally and in terms of logic and code. So I also did that yesterday. I covered all of those things yesterday, and we also looked at how to reverse a linked list. Okay, remove linked list element. Okay, this is what we're going to do today. Now, the idea of linked lists, right? So most of the linked list question you will come across, right, will either require you to create a dummy linked list and copy all the original linked list into that dummy linked list, right? And then work with it and return part of your list, right? Now, I'm saying that because I've actually solved this question before, and I don't remember when I solved this. When was this? It was in June. Okay, early June. So, let's give it a read and understand what the question is asking us to do before we, begin to explain the different solutions for this. So we have given the head of a linked list and an integer value. Remove all the nodes of the list that has node.value equal to our value, and the value is an integer which is going to be our second input, and then return the new head. So here is an illustration for this question. We're given a node like this, a list from 1 to 6, even though there are 6 in between, right? And our input, which is the second input value, is equal to 6. So meaning any node with the value 6 should be removed from the original list, right? And then we return the filtered version of the list. By filtered version, I mean we removed every value, right? Every target value from the original list, and then return the head of the remaining lists. So that's essentially what we're going to do. So we have a second example, which is an empty list, and we return null. There are no follow-up questions. The number of nodes in the list is in the range of between 0 and how many is this? 100,000 or 10,000. Okay, whichever. That's not really important. The node value themselves is between 1 and 50 or 0 and 50 here. And yeah, so there's really nothing else to know. So let's understand what the question is asking us to do, or let's see how we can solve this problem. So, okay. My fault. I needed to erase the board. Okay, let's bring this here. All right, so we are given this list and our target value is 6. So we want to filter every value from the original list, right? Every node with the value 6, or every node whose value is equal to 6. We want to filter all of them and return the filtered version of the list. So here's what we need to do. To remove the values, right, we need to traverse the list, or traverse every node in the list, and check if that node's value is equal to our target value, which is 6 in this case. So here's what we're going to do. We start from here. Our first step is going to be, let me use the blue color. We're going to start from here, right, which is the head node. And we check if this current node's value is equal to our target value. In this case, it's going to be 6. So then we see the next node, right, which is now a node with value 6. Then we need to remove this node from the list, right? And to remove the node from the list, we simply need to direct the next pointer of the previous node to the node after it, right? So instead of 2 directly pointing to 6, we break this connection, right? And we take 2 and point it to 3, right? And we also break the connection here. Then we do the same thing. So we continue. So we move from here to here, from here to here, until we see another 6 again. Now, instead of this pointed directly to 6, we can point it to maybe null, right? And that way we'll remove all the nodes in the list. All right, so one thing we also, so there's an edge case to this question, right? Which is, let's say for example our target is at the beginning, right? Let's say we have a list and 6 was here, a node with 6 was at the beginning of the list. How do we remove 6 from the beginning of the list? Well, this is what I was explaining by saying every linked list question will either require you to have a copy of your original list, or you just manipulate the list itself. So in this case, we are going to copy all the original list into a fake list, right? So we create a fake list with let's say for example head value is equal to 0, so I'll call this node with the value 0, and then attach the remaining of this list to it. So we can say f.next is going to be equal to the original list, which is from 6, 1, 2. Now this is just an example. You know what, let me just write it down here. So we'll have a fake node, right? We'll call this, or you can call it a dummy node. In most cases you will see it called dummy node, but you'll see it called dummy node, but hold on. Oh, all right. Sorry, I was just messing around with that. Let me refresh this page. Okay, it's gone. So we'll create a dummy node or a fake node, right? I'll call it fn, and set this node, the head node of this node is going to be from 0, and this node fn, let me just say fn dot next is going to be our input list. So it's going to be from 6, 1, 2, 6 again, 3, 4, 5, and 6. Now this way we'll be able to remove the target node if it's at the beginning of the original list, right? So here's what we need to do. Again, we'll traverse. Now we are going to traverse the fn list, right? We are not going to traverse our original list because we have a copy of the list now in fn, which is fake node, right? So it's going to be we take this, right? So we are going to have a list like this. So from 0 pointing to 6, pointing to 1, 2, 6, 3, 4, 5, and 6. So we start from here, right? And we check if the next node, the node next to 0, is equal to our target value, right? And in this case it's 6, so we break the connection between these two, right? And we'll take the next pointer of our fake node, the head of our fake node, and point it to a different node, right? So in this case, now we are pointing to 1 now, right? So we remove 6, and we now continue our iteration. So we move from this point to this point, right? And we check if the next node, right, the next node of this node is equal to 6, which is our target node. In this case it's not, so we move from here to here, and then we check again. In this case 6 is the next node's value, so we break the connection here and we attach this back to this one, right? And we break it. Then we move from this point to this point, we move from here to here, right? And then we check again, nothing happens, and then here, and we break the connection here and point this to maybe null. So this is how we will be able to remove um a couple of nodes or elements from our list when we are given the list and a target value. So we'll pass on and write the code for this. But before I do that, let me check if there are any questions. Hello, Ransom. So there are no questions for now. So maybe we can continue with the lecture. Okay, so let's say um dun, 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 dun. Okay, so let me open my code editor now, and we'll solve this question once again. So let's create a file. We'll create the file in the linked list folder. This question is what? Leet code number 203. Remove linked list elements. Remove elements. Right? How many? 203. Okay. All right. So we'll need to copy. Now, with the way I've been conducting this class, right? Um, we will just be solving the questions or providing the solution directly. We'll need to run an experiment, right? Create a list by ourselves, right? Insert nodes in the list, and then answer the question with our prepared linked list, right? So I'll create a new linked list and insert nodes in the list. So we'll need to create a node class, which is the most important entity in our linked list. So I'll call this list node. So which is the basic element in a linked list is a node, right? Or the principal element in a linked list is a node. So we'll start here. We'll create a node class. The node class is going to have some properties, so we need to define a constructor function, right? And pass this constructor function a value parameter, right? That will be passed when instantiating this list node, right? So we'll do that, and we'll say here we'll pass on to create the properties. So we'll say self.value, right, is going to be equal to value. Let's call it val. Just because Leet code called it val, just use val as well. Value and self dot next, which is the next pointer, right, is going to be none at first. Now we'll create our linked list class, call this linked list. Okay, we'll need a constructor function here as well, so call this init. So here we'll need a head for our linked list, so say self dot head, right, is going to be none at first. And when we are inserting nodes in the list, we'll ensure that the head was the first node created. So let's define insert nodes, right, and say self dot not self. So let's create a new node. So new underscore node is going to be our list node, and then we'll pass it a value. So when inserting node, we need a parameter, a value parameter, and here, so we'll say value. Okay, then we will pass on to check if our list currently has a head. If it doesn't, we set the new node as the first node in the list. So say if self dot head, sorry, if not self dot head. So let's use if not self dot head, meaning if self is none, right? Then we can say self dot head should be equal to the new node, right? And then we return. Now we can create a current node to keep track of our head when we are inserting the next node in the list. So I'll call this current underscore node, which is going to be equal to self dot head, right? Self dot head. And then we say while current node has a next node, right? Current node, while current node has a next node, current node dot next, right? Then we can say current node should be equal to current node dot next. But in the case where the current node does not have a next node, then we set our new node to the next node of the current node. So this is going to be current node should be equal to current node dot next. Sorry, current node dot next should be equal to our new node. Okay, and let's see what we can do here. I will print. So I'll create some values. I'll say these are the values we want to insert in the list. I'll use the same values as the input here, so we can just continue from there. This is 1, 2, 6, 3, 4, 5, 6, 4, 5, 6. All right, so with this way we've created the list with the different values in it, and we can iterate through the values to insert the values as node in the list. So to do that, we need to create an instance of our linked list. So I'll call this my list, okay, and set my list to the linked list class, right? I will say for value in values, my list dot insert nodes, I will pass it the value, right? Let's run this and see if there is no error. Then it means we correctly implemented our list, and then we can go ahead to print the nodes from the list. Okay, so there are no errors, so we can continue now. Let's define the function to print the nodes in the list. So we can say this define print nodes. So print nodes like this, and all we need to do is say current node is going to be equal to the head node of this class, self.head, and then we say while the current node has a value, while current node should be equal to, wait, we need to print the current node value first. So we say print current node dot value, okay, and we end this with an arrow so it looks a little bit nice while we are printing it out. and then we set current node to be equal to current node dot next. And yeah, so that's about it. Let's run the print node class here on our list. So I say my list dot print nodes. Okay, so when we run this, you can see our list has been created, right? You can see from 1 to 2 and so on. So now the next thing we need to do is to implement the removal of some values, right? So for this, I'll copy, so we have remove elements, right? So I'll copy this part, right? Let's copy this part. So I'll come down here like this. All right, so we don't need the optional stuff here. Let's remove that. Okay, so we definitely have we definitely need a list node, which is going to be our head node. And yeah, so let's come to this place now. The reason why I won't be able to do this, okay, you know what, let's remove the head node here, because we already have a head node in our list already, right? We are using the list class. Okay, otherwise if we want, we can just define an external function, right, that works independently of the class. So all we need to provide it is the head of our list, right? And then we carry on with the calculations. So we can say current node. Again, I use this to keep track of the nodes, right? So let's start with a basic example with a basic example without any edge cases. So we want to remove nodes from a list, right? So we can say current node is going to be equal to the the head of our list, right? So we can say while the current node has a next value, right? While current node dot next, because we are always going to check the next node of the current node, right? So while current node has a next value, we want to you know what, let me write this function in the class itself so that I can just run it and remove the nodes, right? So let's do it here. Okay, so this is better. Come on. So here's what I need to do. So remove element, right? I'll say so we'll create a current node. I need to remove this part. We can keep the value because it changes from time to time. So this is going to be equal to self dot head, right? And self dot head, and we say while the current node has a next node, while current node dot next, right? We can check if the current node next value is equal to our value, then we remove the node from the list, right? Otherwise, we set the current node to the next node. So if current node dot next dot value, right, is equal to the value we are looking at, so it's equal to value, right? Then we say current node dot next is going to be equal to current node dot next dot next dot next. Okay, else we just remove it from the list. Else we just say current node right, should be equal to current node dot next. So with this, we'll remove all the target values, right? So let me call this on the list here. So say my list dot remove elements. I want to remove 6, right? We'll remove it before printing the node. So this time around we should see 1 pointing to 2, 2 pointing to 3, and so on. So now you can see the nodes have been removed successfully. So that's really good, right? Now an edge case is, let's say for example 6 was at the beginning, right? 6 was at the beginning of the list. How do we remove 6? Let's run this again. You can see we still have 6 even though 6 was our target here. So how do we manage a case like this, or how do we deal with a case like this? Well, for us to do that, we need to, we need to return. Let's just do this. Hold on. Return current node. Oh, sorry. Return self.head. Self.head. All right. So for an edge case like this one, where we have 6 at the beginning, we need to keep or copy our original list and attach it to a fake list, right? And then we iterate or we traverse that fake list and remove every element from after the node of the head node of the fake list, right? After the head node of the fake list, we'll have our original list, right? So we'll remove every value from the fake list, right? And then we'll traverse the head of the fake list, remove every value that is equal to every node's value. Sorry, every node whose value is equal to the target, right? And then we return the fake node dot next, which means the next node that we initially attached to the fake list. All right, so let's do that now. I'll say here this is going to be current node. So we create a fake node. You can call it dummy node, but I just like to call it fake node, right? Fake node is a list node like this, and we need to pass it a value. So let's say we pass it 0, right? Now fake node dot next is going to be our list. So self dot head, right? And then we say fake node here. We copy fake node like this, and with this we'll be able to remove every value from the list. So let's say while current node dot next. Okay, so okay, you know what, strange things are happening here. So instead of returning the head, we'll return fake node dot next. All right, so let's see what we have. We still have this because this is printing the list. So let's say if we had defined the printing function outside of the list, then that would be easier. So let's take this out and put it somewhere here. I'll bring it here. Oh, come on. So this will not have self. We'll pass it a head, the head of a list. List node, right? Head. So instead of doing this way, we can just say print That's head. Alright, so let's see. Okay, so let's remove this first of all. We can see our original lists. So let's try and print the removed version or the filtered version of the list. So say my list, my list remove element 6, right? And this will return a list. So I'll say filtered is equal to this, and I'll pass filter to the print node function. Print nodes and filtered like this. Alright, so let's see. Now you can see the 6 has been removed. 2, 3. Every instance of 6 has actually been removed from our original list, right? So this way we've cleaned up the list and we return the cleaned up version. So let's go ahead and implement this in Leet code. So here we'll create a fake, I'll call this fake node, right? And set this to be equal to the list node head, list node, okay, and pass it 0, and say fake node. The reason why, okay, let me just copy this straight away and stop wasting time. So yeah, instead of doing self.head, we already have head here, right? So you can use head straight away. And yeah, so that's it. Let's see if this will work. It did work, so let's submit this. O of n time complexity. Okay, not sure why that's very low today, but let me see what I did previously. Okay, well, it's essentially the same thing, but I'm not sure why the values. Anyways, that's not a big deal. It works, and we can move on with the next question. So, the next question. So the next question we have here is add two numbers, right? Now I've explained this first one. In case you've not watched that video, or you can watch my previous videos, I've actually explained this question before. So what I would do now is to solve a similar question, which is add two numbers 2. We've seen add two numbers 1, we'll do add two numbers 2. Now I started solving this earlier, but I've not submitted. You can see my submission was not done, so let's clear this part and I'll explain this question again so we can solve it properly. I'll create the file for this problem, which is 445 add two numbers 2. So 400. Since it's the first time, I will not put it in the revision file. Okay, you know what? Let me commit this first. So let's do this. So say git add. Come on. Git commit -m. Come on. Remove element. Okay, I usually put the data structure first. So this is going to be linked list. Linked dash list. Remove element. So this is going to be Leet code Leet dash number 203. dash remove element. I don't even need to put the title, so we need to remove this so that it's cleaner, right? Okay, so let's create a new file for the next question. This will be number, how many? What number was that? 445. Add two numbers too. Leet dash 445 dash add dash two nums 2. Okay, so before I continue, let's see if there are any questions. Yeah, when you submit a question and it passes the test, you are usually happy. Yeah. Okay, so let's see the next question. So add two numbers. Add two numbers 2 is the follow-up question for add two numbers 1, right? Which was an interesting question. I explained this in detail. So I gave a detailed explanation, to this question initially, but I'm going to quickly brush through it and explain the idea behind this. So what this question is about, let's remove this part and bring this. We solved this already, so let me use this image here. Okay, so here are two numbers we've been given, right? And they are represented by a linked list. So these are essentially two integers, right? So, and the digit of each integer is stored as a node in a linked list, and we are going to sum the values within each node and return a corresponding node, right, of those nodes, and set it into a new list and return that list, right? So here's what I mean by that. We'll be giving two linked lists, right? Now this linked list is actually a number or an integer, if you will. Let's say in this case 243, and each of the digits in this integer is put into a node, is represented by a list, right? And each node is connected to the next one, which is what we have here. And the second one too is the same. So we want to sum the values in each node, right, and return a corresponding list or the resulting list from the addition we perform. So what we do here, and a follow-up question is that we do not store two digit value in a single node, right? You can have, in this case, you will have, this is 7, here is going to be 10, but you can't put 10 here, right? Just the way we do normal addition. Let's say, for example, we had 256, 243 and 564, right? Now the addition is, in this case, will be done from left to right, because we are traversing a linked list, right? And we always start from the head node. So let's assume we perform the addition from left to right instead of from right to left. So we start here. This is 2 plus 5 is 7. 4 plus 6 is 10. But you can't write the 10 here, right? So what we usually do is we write the remainder and carry out some values, right? So this is going to be, we write 0 and we carry out 1, and we add 1 to the next addition sequence, right? So this is going to be 4 plus 3 is equal to 7 plus 1 is equal to 8, and we return this as a linked list, right? Just like this. So now the things to note in this when it comes to a question like this is that the list might not be equal, right? And there will be values we need to carry out when an addition results into a value with 2-digit numbers, right? So we need to carry out one value and keep the other. So how do we do this? Well, to carry out a value is it means to divide the result of the addition by 10 and round up the value or round down the value, right? So this is going to be let's say, for example, in this case where we got 10, we simply divide 10 by 10. Now we use the double division sign to round down the value, so this will be equal to 1. Now this is the value we carry out, right? This is our carry value, and the value we store in the node itself is the remainder of the division by 10. We divide any value, right? As long as the value has 2-digit numbers, right, we have to divide it by 10, and then we find the remainder of that division. And luckily for us, to find the remainder of a division between two numbers, we take the first number and we use the modulo operator to find the next. So this is going to be equal to 0. So this is the value we store in our list, in the resulting list. And then the carry out value, you might be asking, what do we do with this? Well, when we perform the next addition, we add it to it, right? And then we check again if there is going to be any value to carry out, and so on. Now the condition to keep iterating, obviously we are going to traverse the list simultaneously, right? But what if there was a list with lesser node than the other, right? Let's say, for example, this node here did not exist and we only had 2 nodes, right? Well, for us to do that, right, we need to ensure that at least there is a node in either of the list, right? So we use a while loop that says while there is a node in list 1 or there is a node in list 2, then keep traversing the list. But there is also a special case. What if there was a value carried out, right? What if we carried out a value and we are now done with the addition? Say, for example, in this case, right, let me remove this part as well, right? This is going to be 7, and this is going to be 10, right? But we need to write 0 and then carry out a value, right? But in this case, with this example, these are the last nodes we have in this list. So where do we keep the next value, right? The value we carried out. We can't just throw it away, right? We need to store it in a node. So in order for us to do that, we need to also ensure that if the carry out value has a value in it, it has a real number in it, right? So let's say carry like this, or while carry, then we continue the iteration, right? So we'll say we add the nodes. So these are a visible node, so we can represent this with 0 and 0. So we add 0 to 0, and then we add 1, right, which is the value we carried out, and we create a new node and set it to 1. So this is how we'll perform this addition in the case of add two numbers 1. Now add two numbers 2 is similar to add two numbers 1, but in this case there are a few things to note, right? So let me clear this console. Now you are given two non-empty linked lists representing two non-negative integers. The most significant digit comes first, and each of their nodes contains a single digit. Add two numbers and return the sum as a linked list. You may assume the two numbers do not contain any leading 0 except the number 0 itself. So how do we perform this addition? Now, unlike the first question, when you observe the image, things are a bit different here, right? Things are a bit different in this problem. When you observe this, you can see that the addition here, so let's say, for example, let's just assume the addition was done from the head of each list, right, by traversing the list simultaneously. So in this case, this is going to be null, so we'll set it to 0, and then we continue, right? So in this case, we can return 7, which is okay. But here, the node is now 8. Now, you might be wondering what's going on here, right? So, what actually happened is that the addition was done from this point to this point, right? So, from the end of the list to the beginning of the original list. So, let's look at the end of the list to the beginning. So, here we have 3 plus 4, which is going to be 7, right? That's correct. The next node is going to be 10, so we have to write 0 and carry out 1 and add 1 to this place. This is going to be 3, 3, 8, and this is also correct. And 7 plus 0 is also correct. So what does this tell us? Well, this tells us that we need to reverse the list, right? And when we reverse each list, right, so the original list will look like this. So we'll have values from this point. Let's just write them here. 3 to 4 to 2 to 7. And we'll have, so the reverse version of this will be 4, 6, 5. And we add each node. So here we'll have 7 pointing to, this is going to be 10, so we write 0, carry out 1, this is going to be 3, this is going to be 8, sorry. 8, and this is going to be 7 here because there is no value here. This can be 0, we can represent it with 0. Alright, but now we have 7087, but our list here, our result here says 7807. It means we need to what? Reverse this result, right? So we'll have to reverse this result back. So this is going to be 7, 8, 0, and 7. So now, what this question actually is the reverse of add two numbers 1, right? So in add two numbers 1, we did not do any reversal. When add two numbers 2, we will have to reverse the nodes, add them, and then reverse them back as the result. So let's pass on to the code and write out the code for this. So I'll come here, let me copy the boilerplate. Okay, let's see here. So first of all, we'll define a function that helps us reverse the list, right? A function that helps us reverse the list. So we can do this. Alright, so let's define a reversal function. So reverse the list is going to be part of the class itself, and we can use it directly. So let's pass it here, and we'll say this will take a parameter called the head of a list. So we'll say this is going to be list node, and here's what we need to do. We need to so to reverse a linked list, we need a previous, and set this to none. we need the current node, which is going to be the head node. So current underscore node. I usually like doing this like this. So this is going to be the head, and we'll say wow, there is a current node, wow current node. Then we need to say we need to keep the next node, a copy of the next node after the current node. So we'll say next nodes, next node, and set this to equal to the current node, right? Dot next. Okay, and then we can say so current node, next node is equal to current node dot next. So current node dot next is going to be previous, and previous becomes the current node. Previous is equal to current node, and current node now becomes the next node. So the next node here. So with this, we'll reverse the list, and we can then return previous. All right, so we now use this as our helper function to reverse both of our lists, right? I think I have some questions. So Galax Boy says, will this journey continue after the 100 days? Yes, it will continue after the 100 days. So yeah, it will continue, but not immediately. I'll have to take some break and come back. I will announce when it will start again. So yeah, it will still continue. No, 365 days. So let's take our lists, right, and reverse them. So I'll say L1 is going to be equal to self dot reverse list L1, right? And then we'll say L2 is going to be equal to self dot the reverse list L2. All right. So just the way we using the steps with add two numbers one, right? So we'll repeat the same thing. So we'll create a carry value, right? The value will be carrying. So initially we set it to 0. Now 0 is falsy, right? So meaning if we have 0, then it means then it means the condition might not be favorable for the loop to continue looping, right? If this is false and this is also false, right, or none, because when we reiterate or when we traverse up to the end of the list, we'll point to null, right, which is the last or tail node in the list. If we reach null and null here, or the tail nodes in these two lists, and carry still has a value, the loop will continue. But if carry has 0, then it means the loop has to stop, right? So now we'll need a placeholder node to keep track of the list that we'll be creating. So I'll call it a fake node, right? So I'll say this is going to be a fake underscore node. Fake node is going to be list node, right? I'll pass it 0 as the value. Okay, even if we don't pass it 0, it will be automatically passed because the default value of value here is 0, so we can leave it like that. So we say current node. So current underscore node is going to be equal to the fake node, right? So we can say while while um while there is a fake node, so this is going to be while L1 or L2, or there's a carry value, right? Then we can say so we say value of the first list, so we'll call this v1, let's call this v1 is equal to l1 dot value, right? If there is a value in f1, right, or if l1 has a value, or if l1's node is not null. So l1 dot, if l1, you don't even need any dots, if l1 else, we return 0, right? Just to keep it in place. So this v2 is going to be the second value of the second list. So this is going to be l2 dot value if l2, sorry, not id, if l2 else, we return 0, right? And then we calculate the total. The total is going to be v1 plus v2 plus the carried out value, right? And then we say carry is going to be equal to the total divided by 10. We create a new node. I like doing it this way. New node is going to be equal to list node, right? And we'll pass it the total, the remainder of the division by 10. So we do this, divide by 10, and we can say our current node dot next is going to be equal to new node, right? And current node should be equal to the current node dot next. All right, and then we need to traverse the L1 list and L2 list simultaneously. So say if L1, right, L1 should be equal to L1 dot next, else, sorry, not else, we'll just say if L2 as well, we'll just do L2 should be equal to L2 dot next. Okay, and the next thing to do is to return, after all this iteration, return the fake node dot next, right? This will return our original list, but we want to reverse it. We want the reverse version of this. So we'll say self dot reverse list, and then we'll pass it the fake nodes next. All right, so let's run this in Leet code and see how this will do. So let's copy this part. I think my time is up, but I'll just try to, I just want to copy that to keep the original inputs, right? So do not panic. So let's copy this part. Now, in case you are, let's run this first. Okay, so this is working. Let's submit. I'm sure this is going to work, but I don't know. All right, this is all right. This is good. The green light indeed makes you happy. Okay, so that is it for this question. I can remove this part now, and let's submit this to GitHub. So git add git commit we can say this is, let's do the linked list 445. Okay, git push origin main. Alright, so this has been pushed to GitHub, and if you want access to the solutions of all the questions I've been solving so far, you can find all of them here. So we solved only one matrix. Oh, wow. Anyways, that's not bad. Okay, so are there any questions on this? Okay, there are no questions. My time is up. And in case you want to solve this question again, there is an editorial available. If you're stuck, you can read through the editorial and try to understand. There are actually two methods. I prefer the first one, right? You can look at this and see how it is done in order for you to understand the question. Anyways, it's been nice, you know, it's been nice streaming today, and I'll see you guys tomorrow. I'm also subscribing. All right. Okay, so that's about it for the day, and we shall see tomorrow. Take care, guys, and have a